Hello and welcome to yet another South Korean College Scholastic Ability Test video, which is the test that South Korean high school seniors take in order to go to college. The test for students who go to college in year 2025 was held only about a week ago, and in this video I would like to take a look at the very last problem in the calculus section, which usually tends to be quite difficult. It says for constants a and b, where a is greater than or equal to 1 and less than or equal to 2, function fx defined as sine ax plus b plus sine x satisfies the following conditions. Condition A, f0 equals 0 and f2 pi equals 2 pi a plus b. And condition B, the smallest positive value of t such that the derivative f prime 0 is equal to derivative f prime t is 4 pi. Let a be the set of all values of alpha in an open interval from 0 to 4 pi such that fx is local maximum at x equals alpha. Let n be the number of elements of set A and alpha 1 be the minimum value among elements of set A. Then n times alpha 1 minus a times b is equal to q over p times pi, where p and q are coprime natural numbers. Find the value of p plus q. Alright, so this is our problem, and this problem can be actually divided into two parts. This lower half of the problem consists of finding the set A, finding the number of elements n, finding the minimum element alpha 1, and calculate some stuff. This part 2 of the problem can be done once the values of a and b are found and we know the exact expression of function fx. These values of a and b can be determined from this upper half of the problem, specifically using these two given conditions. So let's just focus on the upper half of the problem for now. First, let's use these two given values in condition A. Using the given expression for fx, we know that f0 is expressed as sine b, and this equals 0. Therefore, b equals m pi, where m can have integer values. Next, f of 2 pi is given as sine 2 pi a plus b, so this equals 2 pi a plus b. The implication of this is that 2 pi a plus b can be considered as a root of the equation sine x equals x. Usually, an equation containing both polynomial and trigonometric function is pretty tricky to handle, but for this particular equation, we can use the following useful graphical knowledge. The graphs of y equals sine x and y equals x meet only at x equals 0 and nowhere else. I'm not going to prove this in this video, but you can easily verify this by examining the slope of y equals sine x using its derivative. What this means to our problem is that in order for this equation to be satisfied, this 2 pi a plus b must be 0. Therefore, we have b equals negative 2 pi a. So comparing these two, we know that m pi equals negative 2 pi a, so a equals minus m over 2. So a is half integer, and it is given that a is greater than or equal to 1 and less than or equal to 2. Therefore, possible values for a are 1, 3 over 2, and 2. So a can have these values, and since b is given as negative 2 pi a, the corresponding values for b are negative 2 pi, negative 3 pi, and negative 4 pi. Let's now consider the second given condition about derivatives. Obviously, we have to obtain the derivative first, which is given as cosine ax plus b plus sine x, and by the chain rule, we have to multiply the derivative of this inner part, which is a plus cosine x. The given condition indicates that f prime 0 is equal to f prime of 4 pi, so let us obtain both values. First, f prime 0 is given as cosine just b times a plus 1. And since b can only be integer multiples of pi, the values that cosine b can have are either 1 or negative 1. This means that f prime 0 is either positive a plus 1 or negative a plus 1. What about f prime 4 pi? Well, in this case, we have cosine 4 pi a plus b times a plus 1. Here, we use the knowledge that 2 pi a plus b equals 0, which was obtained from the condition involving the value of f of 2 pi. Then the inner part simply becomes 2 pi a, and from here, we know that 2 pi a can have values of 2 pi, 3 pi, or 4 pi, so both positive a plus 1 and negative a plus 1 are still possible. In order to decide which sign to choose, we must use one more given condition, which is that 4 pi is the smallest positive number t satisfying the given derivative condition. This means that the values of the derivative at other points in between 0 and 4 pi must not equal to f prime 0. For example, the derivative at 2 pi is not equal to the derivative at 0 or 4 pi. And I didn't just randomly choose this value of 2 pi. I brought up this example because the derivative at 2 pi is a rather special one that can give us useful information. Notice that f prime of 2 pi is given as cosine 2 pi a plus b times a plus 1. And since this 2 pi a plus b is just equal to 0, we simply have a plus 1. So the derivative at 2 pi is a fixed value a plus 1. Since f prime 0 and f prime 4 pi must have a value different from f prime 2 pi, it follows that f prime 0 and f prime 4 pi must have a value of negative a plus 1, not the positive value. Therefore, from this expression for f prime 4 pi, we know that cosine 2 pi a times a plus 1 is equal to negative a plus 1, meaning that cosine 2 pi a equals negative 1. Among these three candidates, the only candidate that satisfies this equation is a equals 3 over 2, which gives b equals negative 3 pi. So we have found the values of a and b, and with these, we now have the exact expression for function fx, which is sine 3 over 2x minus 3 pi plus sine x. And with this, now we can move on to the second part of the problem. Just to remind you, this second part involves finding the set A, finding its number of elements n, finding its minimum element alpha 1, and calculating this. So let's start from the first part. It is stated that set A is the set of all values of alpha in between 0 and 4 pi such that fx is local maximum at x equals alpha. This means that the sign of the derivative changes from positive to negative at such alpha. Here, notice that the derivative is given as cosine 3 over 2x minus 3 pi plus sine x times 3 over 2 plus cosine x. And since 3 over 2 plus cosine x is always positive, we only need to examine the sign of cosine part. Let's do that with the help of the graph of y equals cosine x. From the graph, you can notice that in order for the sign of the cosine function to change from positive to negative, this inner part must have values of 2k pi plus pi over 2, where k is integer, that is, these values. And let's take a closer look as to how the value of this inner part changes. First, notice that the inner part has a value of negative 3 pi when x equals 0, and a value of 3 pi when x equals 4 pi. The next thing to notice is that this function is an increasing function because its derivative is always positive. So the value of this inner part function steadily increases from negative 3 pi to 3 pi. Now we need to find the values between negative 3 pi and 3 pi that can be expressed as 2k pi plus pi over 2 because that's where the local maxima occur. And it is not difficult to find these three values, negative 3 over 2 pi, pi over 2, and 5 over 2 pi. And there have to be corresponding x values as well. It is given in the problem that the least of these three x values is called alpha 1. And for the remaining two values, let's just call them alpha 2 and alpha 3. So we have found all local maximum points where x is in between 0 and 4 pi. With these found, the rest of the problem is easy. N is defined as the number of elements of set A. Since set A has 3 elements, we know that n equals 3. Next, alpha 1 is the minimum element of set A. So from this value, alpha 1 must satisfy 3 over 2 alpha 1 minus 3 pi plus sine alpha 1 equals negative 3 over 2 pi. And it is not that difficult to find out that alpha 1 equals pi. We have to calculate this expression. So using these values of n and alpha 1 and these values of a and b, n alpha 1 minus ab equals 3 pi minus 3 over 2 times negative 3 pi, which is 15 over 2 pi, and this equals q over p pi. So the value of p plus q is equal to 15 plus 2, which is 17. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.